Welcome everyone. Welcome to the first SNOMED CT implementation webinar for 2021. I am delighted to have Jonathan Olsen, Eric Robertson and Ian Rubin here from BPAC Solutions and KRIS to present on the practical application of SNOMED CT in clinical decision support and integration with GP health records. Before I hand over to them, I'd just like to advertise a few upcoming events. In addition to these SNOMED implementation webinars, we also have SNOMED research webinars and SNOMED clinician webinars. So next week at our next research webinar, Dr. Hugo Menz from Chipsoft will do a presentation on utilising the SNOMED CT hierarchy to generate patient-friendly clarifications. Then keep an eye out for our next clinician webinar the week after, which is still to be confirmed. And then following that, we'll also have another SNOMED research webinar presented by Dr. Rachel Richardson from the University of Michigan. And in addition to the implementation webinars, we have recently opened up the call for abstracts for this year's SNOMED CT Expo. The Expo is currently planned as a hybrid event, both in person in Lisbon and also virtual. It will be available on a virtual platform as it was last year. So you're invited to share your SNOMED experience with a global audience, either presenting in person or virtually through the platform. Abstract submissions close on April 30th, so please visit snomedexpo.org for more information on how to submit. And now I have great pleasure in passing over to Jonathan, Eric, and Ian. So Eric, would you like to share your slides?
Yes, I will. Okay, thank you for that, Linda, and thank you for the opportunity to present to the group today. So just give me a second, I'll get some slides up. So hopefully everybody's got a first slide in front of them at the moment. So the presentation that we're going to do today will take you through a little bit of the history and background around how we've managed and dealt with the opportunities and the challenges that using ontology and terminology and clinical decision support have occurred within our organisation. So I'll take you on a little bit of a background around our organisations, BPAC Clinical Solutions here in New Zealand, and KRIS, our subsidiary over in the UK. So to introduce the team, Jonathan is our solution architect. He's based here in Dunedin with me. I'm CIO for the organisation, and Ian Rubin is our medical director, clinical director, and he's based in the UK. So we'll take you through a little bit about the architecture that we use for clinical decision support, and then Ian will hand over to Ian, and he will take you through some of the detail around our practical implementation in the UK. Just move through the slides. Bear with me for a sec. Okay, sorry, I just can't get a slide for once. There we go. So we're away now. Okay, right. Okay, so we're going to talk about today about the solution architecture, the value sets that we use in decision support and how we leverage those. The places that we're using value sets to overcome some of the deficiencies or challenges and the PMS APIs, and then a little bit about managing updates in SNOMED CT. So I'll hand over to Jonathan in just a second, but a little bit of a roundup about our organisation. BPAC Clinical Solutions was established back in about 2006 and focused on delivering fairly rudimentary at the time clinical decision support for general practitioners in New Zealand. Our organisation was led by Professor Murray Tilliard, who is a practicing GP and Professor of General Practice in Otago University. And he was recognising some of the challenges as medicine became more complex and managing diseases became more of a burden on the general practice group in particular. So he began the organisation, or started the organisation, and built around him a team of clinical and technology experts to find ways of making the management of disease much more consistent across the population. One of the key aspects of managing disease was around leveraging ontology or leveraging terminology to understand how the patients were currently being identified and managed. In the early stages with the work that we did, the core coding system used in New Zealand for general practice is Read 2. And so the early work that was done in New Zealand was leveraging Read 2 coding and applying decision support around that. As the global move began around adoption of SNOMED, the SNOMED CT, coincided with some fairly major work that we were doing on our technical platform, and we took a strategic decision to base our clinical decision support logic primarily around SNOMED CT at its core. And Jonathan will talk a little bit about how we do that and how we leverage the ontology to help provide decision support and guidance for general practitioners. So the organisation has expanded. We currently operate across New Zealand, Australia, and the UK. We have a fairly small but important footprint in England. We've got a fairly large footprint now in Australia, particularly around electronic referrals, which have embedded decision support logic built into them. And so Ian will talk about the UK use case, which we think is probably going to be interesting for the group. So the product set that BPAC and CareIS run is all built on the same technology platform, and we deliver effectively 4 core products. We deliver clinical decision support modules, and those are applications that run in the context of a patient for use by general practitioners at the point of care. So they're providing guidance and support for the GPs as they're managing complex diseases and comorbidities. So things such as CKD or any of the other major disease groups. I mentioned before we have a solution set around electronic referrals. Providing good quality referrals into secondary care, from primary care into secondary care, is a challenge in most jurisdictions as far as we have seen. And what BPAC did was to take the core decision support logic and rationale and solution and use those decision support forms and logic to help to drive good quality referrals. So using SNOMED coding to determine eligibility, and using the coded information within the patient's clinical records to augment the referrals that we're going through into secondary. So we have referrals running in New Zealand, across several states in Australia, and we have a whole of state contract for GP e-referrals in Queensland. And we had a small pocket in the UK, which is really just a beachhead for us at this stage. The second product that we're focused on, or third product area that we're focused on rather, is MCCR, which is Mccr Choices Register. And that is a palliative care register that, again, built on the same platform. And the register is intended for use across the continuum of care for palliative care patients. So providing guidance for the GPs, ambulance services, rest homes, and hospice. So providing a consistent view of the patient's care choices. And behind that is some embedded logic around supporting the right choices for those patients, and driven again by the underlying terminology that or the underlying coding that we're pulling out of the EHRs. Care Navigator is a solution that we have had running in the UK, and we're in the process of launching again in New Zealand. And that's a care triage, first level care triage tool for use by receptionists and frontline staff to help to guide, navigate patients to the right level of care. The product was developed to help to deal with the overflowing waiting rooms in general practice and long queues for GPs. And it did that by looking at the requests that the patients are making in the context of their underlying conditions. So again, leveraging the coding that we draw out of the EHRs, using the SNOMED codes to determine the criticality, to look for immunocompromised patients, to look for critical patients that are on long-term medications, to help direct their care either to a GP appointment, an urgent GP appointment, or somewhere down the continuum of our care staff through nurse appointments or self-help at home. So all of that product set is built on the same technology base, which Jonathan will take you through in a short moment.
Cool, thanks, Eric. So you just want to quickly run through the platform that we've developed to build these, to deliver these clinical applications Eric just discussed. I guess the core requirement of this platform is to build a system that's content driven, so it enables not so much developers, but more clinical SMEs to build these applications. And I guess the other core tenet of that was to have a standards-based system. So wherever possible, we're using standards like HL7 standards, FHIR, and SNOMED CT. So the core sort of components of the system were, we've got an identity service. It's using OpenID Connect OAuth standards. It's integrating with smart cards in NHS. It's and utilising Navigator for authentication in Australia, and it's doing sort of a federation to Azure AD and stuff like that if needed. We've got an audit service to make sure all actions that are done within the system are audited correctly. Got a provider directory that's mostly used by our referrals and messaging components, but it's a FHIR-based provider directory. A messaging component is around delivering messages like referrals using standards like HL72 messages to deliver those messages between providers. And another very cool component of this is our integration. So we've managed to integrate with a number of GP practice management systems and all the EHRs across New Zealand, Australia, and the UK. So to do this, we've built an abstraction over these EHRs interfaces to provide a standards-based FHIR interface, because that doesn't tend to exist at this point for most of those systems. And then we get sort of clinical components. As I said, this platform is built around being content driven. So we've got 3 core systems that we've built to do that. One's a form system, so it's a form engine that builds 5 questionnaires, and those 5 questionnaires are executed in most of our applications and our referrals product. And those are developed in-house with our clinical content developers. We also have a clinical rules engine, which we've built. It's currently mostly bespoke engine, but we've started to build some CDS hooks types interfaces to make this more standards compliant. And we're looking forward in the future to maybe look at utilizing those CDS hooks interfaces properly and also maybe looking at CQL as execution in the background. And I guess the interesting topic for today is around the terminology service. So terminology is a core component of our system as well. So we've chosen Onto server, Cyrus Onto server to be as our terminology server. This is a FHIR compliant terminology server that we've used. We've chosen Cyrus Onto server. However, the interface that it provides is FHIR. It's a standard base, so we could really put any type of FHIR terminology service in there, but we've chosen to use this server. This allows us to hold our terminologies, the SNOMED or LINK or any sort of FHIR code systems within it. We're currently using this to hold those, as well as we also imported CTV3 and read codes and as FHIR code systems, and also concept maps to map those between our different terminologies. So we utilize the service to store and execute our internally developed value sets and concept maps that are consumed by our various applications in the platform. So where is terminology used in our platform? So it's used in a number of places. So we're utilizing our EHR integration to categorize the coded data that is within the patient record, and we use that to categorize it into the various FHIR resources, observations or problems, etc. We're also doing mapping of the data that comes from the EHR, from their native code system, like read and CTV3, to SNOMED. We're also, value sets can be provided to those APIs to actually filter the data that's within there to the data that's required by our applications. Within the rules engine utilizes value sets and it's executing value sets to categorize the coded data to be utilized in the rules logic. Our questionnaires, our forms, it provides select lists to utilize in the UI, and it provides ability for us to filter some FHIR data out of the EHR for display on the form or for logic on the form. And finally, in our referrals product, we're utilizing value sets to pre-select certain data from the patient record to automatically include in the referral as well. So I'll just sort of briefly go through a bit more detail around a couple of examples around mapping and how we're using our mapping and value sets within the system, how we're calling the Onto server, our FHIR server. So just on the left, we've got sort of a diagram to show how the maps are generated. So we are authoring our maps within Snapper, which is a tool that we're utilizing to actually author those concept maps. We're also importing other maps from external sources like TRUD in the UK. They get imported into Onto server. then we have our integration component, which was probably declined, which will extract the coded data from the EHR. It will then pass those codes that's found in the EHR up to our Onto server to do the translation. We're also doing a bit of pre-population cache to optimize that mapping function. And so on the right hand side, you can see this is a sort of request we're making to do a translate FHIR against the FHIR concept map, which returns the matching SNOMED code. And finally, just a quick example around how we're calling our terminology server to do the map, to do the expansion of the value sets. In this case, we've got some coded data in the patient record. We need to validate what of those codes, which ones of those codes are actually within that value set that are defined. So you can see there's a series of codes that have come from the patient record that were listed there, and we've also there's been a value set that's been defined and stored in our terminology service. That query will then go off and it will find all the codes that are actually in the value set and also in that list of concepts. And you can see it's matched one concept there. Cool. So I think Ian's, we're going to take over and talk more about value sets for decision support.
So I'll just stop sharing and then Ian can pick up. You're on mute, Ian.
Thanks, Eric. And I should just be able to start the presentation. Can you see that?
Yes,
we can.
Excellent. So just to illustrate a bit further what Eric was saying, I was once a general practitioner and wandered off and did a number of things, and about 8 years ago was toying with the idea of going back into general practice and decided that things had changed so much that I would need some clinical decision support. Did some ad hoc market research amongst general practitioners in the UK and identified that there was a significant need for that sort of technology, looked around and ultimately found a partner who couldn't be any further away than BPAC, and we've been working together now for about 8 years looking at this. And what I'm going to talk about is really an evolution of the history over that period. So things have moved on significantly from when we started in 2014, when NHS England, and I'm going to talk specifically about England, it's not the UK, it's England, because the NHS is organised essentially around each of the 4 countries. And in 2013, NHS England had awarded, NHS Digital had awarded a contract for general practice record systems in England. And we find ourselves now with three players in England. There is a fourth, but they have so little market share, it's less than 1%. We don't count them. So the market is dominated by EMIS and System 1. There's a third player, Vision, who's about 8% of the market, who is more important in Wales and Scotland. These systems have been around for some time, and EMIS and Vision both used Read 2 in 2013. System 1 used CTV3. The NHS ordained that they should transition to SNOMED CT, and through this last 8 years we've seen that transition happen. It was quite painful. We saw one stage System 1 returning SNOMED CT codes, but when we mapped them back to the CTV3 codes, we saw significant discrepancies in what we were anticipating, and had a significant conversation with them and NHS Digital about sorting that out. Vision continues to export Read 2 and its API. How it deals with allergies and intolerance, we haven't worked out yet because we're just in the process of getting integrated with them. But one of the issues still is, although that in the new contract, which came into place last year for the GP record systems, NHS Digital ordained that the APIs should talk SNOMED CT, UK extensions, and DM&D. EMIS and TPP, who are the manufacturers of System 1, continue to break that standard and use product and substance codes in their allergies, which are not from DM&D or SNOMED CT UK extensions. They use, in EMIS's case, their own namespace within SNOMED, and in System 1's case, they use their own proprietary dictionary. And System 1 has additional problems in that if you get an allergy to a device recording the record system, it actually doesn't send anything, any coded data back at all. It just gives you some free text. In fact, originally we got nothing at all. It was only when we talked to them that they said, yes, okay, we'll give you a block of free text. But ultimately, it is still uncoded data. And then allergies to combination products was a real problem as well, because essentially it returned the code for the first element in that combination and didn't return anything else. And it returns it still as a block of text saying, this is a combination product, here are the constituents. So it's evolved, it's still not perfect. And what I'm going to talk about is a little bit more about how we have gone through the process of implementing SNOMED CT in the UK over the last 8 years. So the first thing I'm going to talk about is the Care Navigator product, which Eric alluded to earlier. This was designed to help, as he said, reception staff identify what the best endpoint for a particular patient was, and they would phone up, and this sitting on top of the GP record system would be in the background answering a whole load of questions, and they could select any number of conditions, urinary tract infection, cough, whatever. I used to use cough as my best example, but unfortunately COVID has completely messed that up, because the example I used to give was that if a patient complained of cough, in the background there was a value set which would say, has this patient, or there was a rule which said, has this patient started on an ACE inhibitor in the last couple of weeks, and there was a value set which said, these are the products containing an ACE inhibitor. Now, of course, COVID has messed that up as an example, but in this example, the patient is complaining of a chest infection, and the background, it has said, oh, the patient has chronic obstructive airways disease, and the patient is also taking a beta blocker. And that will drive the decision, and this won't be self-management in this case. So if we just move on and look at the question of beta blockers, this was the early days of us doing this, and we produced a value set which contained essentially a group of drugs who had a manufacturing dosage form and contain a beta blocker. And we were interested in solid dosage forms, oral dosage forms, or ocular dosage forms, because there are reports of ocular administration of beta blocker exacerbating a respiratory disease. And obviously we are dependent on the expression from the inferred concept to do this, and the capability that Sarah has within Onto server to create these value sets based on these attributes. And that's worked well for us. We also had another example where the receptionist might be phoned up and asked for a repeat prescription, or that there may be some question about whether or not this patient was experiencing some forms of withdrawal or had an addiction. And so in the background, it's gone off and asked whether this patient is on a drug, and we use the controlled drugs category status in the UK here, which is an attribute coming out of the NHS's DM&D dictionary, which I'll talk about in a bit more detail later on. So again, an interesting way or useful way of being able to manage that, manage those value sets, and not to have to come back and revisit it every time there's an update to SNOMED CT UK extensions. There was another use case, and that was diarrhea. does the patient is complaining of diarrhea, should we be worried about it, or is it just normal infective diarrhea in a young fit person, and self-management is the right recommendation for the receptionist to give? So with this patient, does this patient have anywhere in the record an inflammatory bowel disease? And interestingly, when we showed this technology to a group of general practitioners, they went, but it's just like 111, but you've only asked 5 questions, they asked 49 questions. So it's essentially trying to do the same thing in a much more user-friendly way by answering most of the questions from the record system. So here we are, our first attempt to develop a value set for inflammatory bowel disease. We included these 3 in the, and exploded these 2 and included history of inflammatory bowel disease. And in the QA process, I was looking at that and going, oh, that's odd. There are not a lot of Crohn's disease codes in there, and which obviously caused me some disquiet. And at the time, I was on a very steep part of the learning curve about how the whole thing worked, and looked up Crohn's disease and realized that Crohn's disease didn't map back to inflammatory bowel disease, but maps to inflammatory disorders, the digestive tract, and disorders of granuloma formation. Decided that the best way of dealing with it was to use the NHS's own definition of inflammatory bowel disease, and as a consequence went back to that value set and decided that we needed to modify it. And essentially what we've done is added Crohn's disease. We didn't go back and add inflammatory disorders of the digestive tract, because that brings in far too many additional concepts which are not relevant to this, including things like gingivitis and so on. So we added this, but we also needed to ensure that we didn't include patients who had Crohn's disease in remission, although you could argue that that may be not a good decision in that the Crohn's disease may be relapsing. But we were also saying we weren't interested if the only code we could find was Crohn's disease, the soft tissues. So that's now the value set that we run with, and that's been seen as fit for purpose by the clinicians who we work with. So I'm going to move on from the concept of the use of value sets and rules in clinical decision support to assist receptionists in triaging patients and talk about referrals. And Eric's already talked about this. This is a screenshot of the application as presented in the UK marketplace, and it's pulled in the demographic information out of the record system. There's a lot more detail than showing here. And actually, you can see it in a concertina further down on the screen here, patient information. And the user essentially has an option to select any of about 80 referral forms, and those referral forms each have associated with them a set of rules in terms of what information is required before that referral is accepted as complete and appropriate. The thing that we were trying to achieve was, as Eric's already indicated, was improve the efficiency. So effectively it's pre-populating referral forms, so saves a lot of time. It's doing this thing about ensuring that they are appropriate, because the commissioners are anxious that the referral rate continues to skyrocket, and particularly now that the health service has been completely diverted and waiting times are well over a year. There's even more emphasis on ensuring that referrals are appropriate. One of the complaints that secondary care has always had is the referral which says please see and advise, which is not very helpful. And final thing was to ensure that they ended up in the right place. So the back end of this, integration into the referral service and matching codes around the actual selected referral to the services delivered in the referral service by their service directory was the method that we were using to direct them appropriately. So I'm just going to go through a couple of screens and show you what's happening. So in the background, it's identified a set of medication that this patient's on and populated it. And you can then either select them individually or select all of them. And it's pulled through allergies and intolerance. And the young lady here is a test patient, and you can see there's an awful lot of allergies in here simply because we've done a lot of testing around making sure that allergies were being pulled through completely. What we identified was, in fact, things like lactose intolerance wasn't treated by one of the record system providers as an allergy intolerance and wasn't being pulled through based on the way they managed allergy intolerance within the XML that they provide within the API. So again, another use case where we've gone back and generated a value set based around SNOMED CT UK extensions in order to ensure that the allergy information was complete. And in fact, latex foam allergy is also another instance where those were not being brought through by the API in the form, in the presence, in the way we would anticipate, or we were being told by the providers it would be. So the use of value sets again has been extremely useful, built around SNOMED CT and the ontology. So there we go, lactose intolerance. The other problem here, as you can see, is combination products. And again, what we were seeing was codes coming through which actually identified the first constituent in the combination, but ignored the fact that it was a combination and the allergy might be to the other constituent. So again, that required some negotiation with the primary system vendors in order to get the APIs updated. Another use case was population of social history. We want to auto-populate the social history in this referral, and how do we go about doing it? Although there is a construct within the EHRs that this is the social history, and you can identify that apparently in the XML of the API, it turns out that that's not actually true. You can put social history in as a user essentially anywhere in the health record system, and it therefore doesn't appear as you'd anticipate. And so you get inconsistent return in the XML of the information that you need to populate into the referral. So essentially, we've gone and looked at this, but we need to exclude occupation, ethnicity, and language because they populated different areas of the referral form. And to achieve this, essentially, we've created a value set which is based around, or initially based around social and personal history, social context, or social content finding, and then legal, financial, employment, and or social and economic history was in there, but we were taking this out, which was occupation, ethnic group, language, and ethnic group finding, because they, as I said, were going elsewhere. But this caused us a problem, and what we did was change it so that we extended it to include social and personal history finding, to increase the scope to make sure that we were picking everything up, but then added this to the exclusion to make sure that we weren't duplicating language in the social history, whereas language is already populating another area within the form. So again, the ontology has proved extremely powerful as a way of dealing with populating the form appropriately. So I hope you can understand, based on that, how we've gone about using the technology to help populate the forms. And in the background, I'm not showing you the rules engine, but it also is running a set of rules in terms of the things that Eric talked about. Is this a referral appropriate? Is it complete? So what I'm going to do now briefly is add to what I've started to touch on, which is some of the deficiencies in the Pms8 APIs, so the electronic health record system APIs. And I'm not going to tell you whose is whose, but if I go to the next slide, we had a complaint from an end user a couple of years ago saying, I'm about to make a referral with suspected prostate cancer. I've got a serum PSA in the record system, but it's not appearing in your form. So here it is, patient 1. You can see what's populated the form, and you can look at the dates. On January the 18th, 2019, there was a PSA in the record system, but it doesn't appear in our referral form. And we scratched our head hard, and I'll come back to what the solution was. But again, we saw that in another patient, it wasn't just a specific issue with one patient, because we were concerned there was some underlying issue with the data in that record. No, it wasn't. It was a common problem. A number of patients, a number of users were saying to us there was the same problem. So if you look at the XML returned by the API, it essentially says, and I've told you this one is EMIS, we have different types of XML here. And what we were anticipating that is that if it was a laboratory test result, it would come out in event type 5. Sorry, the PSA was actually coming out in event type 5, whereas ours was looking at a different event type to try and answer the question, is this a laboratory test result? So by the solution was essentially to go and take everything, which is all observations, so all coded data, filter them using a laboratory bounded value set to identify all laboratory test results, and to use that as the route to populate laboratory test results into the form. So again, specific use of that. And I think increasingly we're moving away from these sorts of event types to focusing very much more around the actual contents of the record and using value sets to filter them into the right place, into the right rules. If we look at system 1, which is the major competitor, the XML is interestingly constructed, and there is a need to actually go back and look at the XML, because although you can get the observation out, what this XML is doing is actually allowing you to do a number of things. And in here it's saying, well, it's a pathology test, but it's also that the user has said there should be a follow-up action. In this instance, there's nothing, but whether there's further action, no further action, and then the follow-up actions here. So this is an incomplete diagnostic report, but what this XML does is contain additional information which is not related directly to the SNOMED CT code. In this instance, actually, I'm showing you some old data using CTV3 coding. But the point is that we still have to look at this in order to get a file resource as a diagnostic report. And as you can see on the right-hand side here, I've got a different patient and it's a different test. It's actually a white cell count, but it's been returned as a diagnostic report, but containing that observation and the value at the end here. And it tells you a whole lot of other things as to when it was done, and that's related to the sample rather than anything else. It's also in this resource telling you how many tests were actually recovered from the record system. So still a fair amount of work to take this to convert it into something useful as a file resource. And this file resource is what we talk to us and all of our partners in terms of the integration process. So the final thing I wanted to talk about, I'm not quite sure I'm doing for time, is query table and historic substitution and the intentional and extensional value sets. The issue that we faced was that at some point in time, we decided we'd create a value set, and we internally had a lot of conversations between here and a number of people in New Zealand about how we managed this whole issue of value sets as they became inactive. And we developed a procedure which essentially said that we will create a value set and we will run that query against SNOMED CT UK extensions using SIRO, and we will expand that and we will use that within the decision rules engine. At the point that there is another release of the UK extensions, we release the process, repeat the process, and then essentially combine the old and the new, so that any that have been inactivated are maintained. The problem with this is that it was laborious, but it also had the problem that it was an arbitrary starting point, and we couldn't identify codes which had been written into the record system some months or years ago before we'd actually created our first instance of the value set and had been inactivated. So we needed a solution, and we looked around, and in the end, the obvious thing to do was to look at the history substitution table, and that allowed us essentially to go and find any code which was in the current version of the value set and see whether that mapped to any historic or inactive code, and pull those inactive codes into the value set to ensure that we were not missing concepts which had been inactivated. And it was funny that I was looking at some work that NHS Digital had done and around allergy intolerance, and it looked like to me that they were not picking up inactivated allergy intolerance codes. So that's now a solution that we have, and the great advantage is it can be automated and it doesn't need human intervention. And it overcomes the problem that we originally had, which was that when we started was a purely arbitrary point in time, given the evolution of the ontology and the activation status of individual codes. And I'm going to now drift, I'm afraid, a bit more into UK land, just to talk about how these codes become activated and inactivated over time. In the UK, we have an extension called DM&D, but it has a completely different data model to SNOMED CT. The reason it's important to us is that it's updated on a weekly basis and it's released on a monthly basis, where SNOMED CT UK releases have been less frequent than that. And as a consequence, we've had to look at DM&D in order to make sure that we are up to date while SNOMED CT UK extensions is catching up. And if you look at this, we have on the right hand side here virtual therapeutic moiety, and then underneath that the virtual medicinal product, an actual medicinal product, and then there's a pack for the virtual medicinal product and the actual medicinal product. And in this instance, we're looking at afatinib and the 30 milligram tablet, and those map ultimately to those codes within SNOMED CT. But if you look at this, and you can see that that actually the code that this is actually an NHS Digital presentation from a few days ago. They've used this code here from SNOMED CT, but in fact it's an inactive code, and there's the virtual therapeutic moiety. The actual medicinal code has been inactivated, and although ultimately or early on in the earlier releases of the ontology that code was active, it's now been replaced by what is actually originally a DM&D code. So you can see DM&D codes coming in and replacing SNOMED CT codes, and the SNOMED CT code being inactivated. But we can also see new products coming in and then being added to the ontology. Here's another example where things have gone the other way round, and we've got a product here, benztropine, which had this DM&D code, and it seemed to be the same as this, and this code has been inactivated. And if you go back and look at that, you can see that that is an inactive code within the UK extensions now. So that helps us manage the evolution and the interaction between SNOMED CT and DM and D. And at that point, I was going to stop, and I think we were going to take some questions. So I stopped sharing the screen.
Thank you so much, Ian. That was wonderful. Ian, Eric, and Jonathan. We have some time for questions. So what I suggest is if anyone in the audience has a question, please raise your hand and we can allow you to talk, or you can add something to chat, whichever you prefer. So does anyone have any questions? I can't see any hands raised. I found that a very simple yet elegant approach to using the historical substitution table in. I thought that was a wonderful idea in terms of being able to pick up the inactive codes that have a historical relationship to an active code. So
it was Linda, it was very much self-interested. John Fountain, who used to work for BPAC, and I had endless conversations late at night about how we were going to deal with this problem. And my anxiety was it was just going to be too onerous to do it the way we originally planned to do it, and was thrashing around trying to think about it, and realized that the substitution table could be used in the reverse direction to achieve what we wanted to achieve.
Yes, it's surprisingly elegant, isn't it? It's a wonderful idea. I see a few comments in the chat. Anyone who would like me to turn their microphone on, I'm very happy to do that. I see Sander has a comment in chat, so Sander says, I'm afraid we're not able to implement SNOMED to the extent in the Netherlands yet, but it's inspiring to see how you handle these issues. I hope we'll be able to follow you in the coming years.
It is really good. I mean, having started with Read 2 and CTV3, I'm a big evangelist of SNOMED. It has evolved significantly over the last 8 years in a way which has been very useful.
Wonderful. Aditya Panandi has asked, what proportion of inactivated codes are not mapped to an active replacement?
I don't have an answer to that question, I'm afraid.
Neither do I. If anyone on the call hasn't answered that. And Sander's fine. Does anyone else have a question? I don't see any hands raised, but I'm happy to unmute you if you would like to talk. Alessandro Santos has asked, I didn't know this concept of SNOMED. Is this tied to a particular medical department? Alessandro, I wonder if you could clarify whether you're talking about the implementation. Ian, do you know?
I'm not sure what the question means, and essentially there is no linkage between SNOMED CT and any particular medical area or department, so it is very, very broad.
Great, thanks, Ian. I can't see any other hands up. So if there are no other questions, then oops, someone's hand just went up. Let me find where that is.
Hi, this is Yong from
Yong.
SNOMED International. It's really a great presentation, and really happy to see the application of eCell query used in a more advanced way to look at different configurations. I think also interesting to see the historical substitution table being used for the query. That has been quite a few years work in SNOMED in UKTC originally designed. My question here is, when you apply the substitution table, do you also use that for the query? Because that was one of the design requirements. As you mentioned, you use those eCell query. It's likely even that query, the concept in the query actually had become inactivated and then needed to be updated. I don't know if you use that as well. Not only just use active looking for inactive, actually it's the other way around, from inactive for looking for the active.
So essentially most of our use cases are built around looking at a code set returned or set of codes returned from a record system. So our most of the time we're trying to add inactive codes to our value set. There are obviously situations where we are using a value set to write something back into the record system, but we would seek to update that value set based on the latest release. I'm not sure we would use the substitution table in that setting. Now, I'm not sure I've understood the question right. Is that a sensible answer?
Yeah, I think it's a sensible answer. I think my question is, in your demonstration, you use quite a lot eCell query, right? And those as a part of, I assume that is part of a configuration. How do you decide those list of concepts to be used for looking for the patient and the decision support? When doing that query and even that specification, the eCell specification, the concept as part of it could become inactivated. So therefore, the query actually becomes smaller and smaller because or even bigger because those constraints have been changed. So that is one area we're looking at. Basically apply this substitution table not only in the result, but also in the eCell query. Yeah.
And I understand now. So the answer is no, we haven't done that, and I guess we might want to think about that. Historically, what we've done is essentially rerun it and said, has it got smaller? It's not likely to have got smaller. It should have got bigger. If it's got smaller, then we worry about it. If it's got bigger, we tend to be more relaxed about it.
Yeah, it's really good to see you've done that work and to get more record back, because otherwise quite a lot of people assume if you use today's latest release, you will get all the patient record back. Actually, it's not, because in the past, the concept used now become inactive. So therefore, default query actually won't get those back. Thanks for that, yeah.
Yes.
Sorry, while you're there, Yong, are you able to answer the question of what proportion of codes do not have a substitution defined?
Yeah, when we started the first design, we really focused on the substitution table. We really focus on the same as relationship, because we know that definitely is we can find the substitution. But for maybe those are quite challenging. Not all of that have a good substitution. So those are in a big document. There's a big document developed by NHS Digit to talk about in great detail. So that means not all the concepts you can find a good replacement. That substitution sometimes still require the human intervention. I think the majority, as long as that has the replacement, that's safe to use. And for those are not safe to use, we were reluctant to really provide a substitution. I think this, I don't know if, because I left NHS Digital quite a few years already, I don't know if that has been developed further to include more substitution, like, you know, for ambiguous concept, to provide one or more, because that is always challenging. If you provide two or more substitute, then you know, the user has to decide which one is appropriate, which one is not. So that's also make the process a little bit harder. Yeah.
For us, it was not such a challenge in the sense that we wanted to apply a filter and make sure that the filter was wide enough, and if we had ambiguity, as long as we were picking it up, it wasn't an issue. But you're right, if you're trying to change a code or substitute a now inactive code, obviously it's much more of a challenge. Yeah,
you're right. It depends on use case. Yeah, for your use case, say, okay, if you have more broader substitution, I'm okay with it. I get more patient record back, right? Yeah.
Yeah.
Great. Thanks, Tom and Ian. A few other comments have come in from Aditya Panandi. I saw in the presentation that Valida records allergies using the adverse reaction to codes. Are allergies more generally recorded in the information model against the SNOMED ingredient concept, or are the adverse reaction to allergy to concepts used? So the substances or the clinical findings.
So the record systems provide for recording it as a construct against a substance or product, or to write in a SNOMED CT code for a specific allergy. And we see both, and we manage both. It's probably more down to the individual user, though I suspect from the data that we've seen, it's more common for it to be returned as a construct against the product or substance code.
Yes, I've actually done a survey of national allergy subsets, and I found that it is more common to use the substance code for allergy checking in different countries. So that's just my observation. I see Denise has said in the UK, NHS Digital also provides a query table which has a value that indicates whether the relationship is same or maybe. This means that the use of the table needs to decide which aspects to include. Did you want to add anything to that, Denise? I can take you off mute if you...
Hi, Linda. Just to say that we have a document that's with the query table. I think they're both in the same pack. So we provide something called as Ian said, the history substitution table, but we also provide something called a query table, which does take into account all the different relationships that might have caused a concept to be inactivated. And so the table also has a column in that says how likely is this to be a good replacement, if you like. And depending on what application you're using it for, you can decide, using that value, you can decide how far to go in using that extensive range of relationships. But if anybody's interested, it's probably better to read the document that's associated with the query table so that you've got the full details.
Okay, thanks for that. And I see Pete Turnbull has some comments to add. So did you want to add something, Pete?
Hello. Yes, just to say that the one thing to note with the query table is that it does a subtly different job to the history substitution table. Rather than replacing an inactive concept with a replacement concept that is active, what the query table does is it takes inactive content and it puts it back into the SNOMED hierarchy. So you can use its historical relationships to basically report on ISA relationships for inactive content. So it does a subtly different job, but sometimes that's a more appropriate thing to do. It depends on your use case. It basically extends your transitive closure table to put the inactive content back into the hierarchy is how it works. And as Denise has mentioned, you can choose certain levels of ambiguity, which can enable you to, depending on the use case again, say things like, I will happily accept false positives rather than false negatives, so I'll accept these codes as well. Or if you're more risk averse and you don't want false positives or false negatives, you can just have things that are of low ambiguity. So there's various different sort of levels and settings you can use it at. The other thing about the read codes and the mappings is that we always intended the mapping tables from read and CTV3 to SNOMED to be temporary. If we had continued to maintain them, people would have stayed with read longer, and we're trying to push people away from read now and into SNOMED. So they will increasingly start mapping to inactive codes as SNOMED develops and as SNOMED moves on, whereas read and CTV3 are now stationary. So using history substitution, as Ian has done, perfectly valid way of maintaining your own mapping tables, but it was a conscious choice that we didn't want to do that nationally. But if anyone wants some advice on maintaining their own mapping tables from read and CTV3, do get in touch with us at NHS Digital and we'll be very happy to speak to you.
Great, thanks very much, Pete. And Peter Williams has a comment to add, so I will let you add that yourself, Peter. If you're able to unmute, then you can share your comment by audio. Oh, in a noisy environment. Sorry, I didn't see. Okay, so what Peter says, running a rough query just based on the existence or not of a historical association for an inactive concept exists is 120,055 and does not exist is 11,981. So roughly 120,000 has the historical association and 11,000 doesn't. So the large majority does, based on my understanding of those numbers. Thank you very much, Peter. Are there any other questions or comments from the audience? I don't see any hands raised and I don't see any other comments. So I'd just like to extend a huge thank you to Eric, Jonathan and Ian for a wonderful presentation. That was really interesting. Really enjoyed that. So thank you so much. And I hope everyone enjoys the rest of their day. Thank you so much.
Thank you, Linda.
Thank you.
Thank you.